When we looked at the history of AI, a lot of the examples we discussed were algorithms designed with a particular purpose in mind. This is what's known as narrow AI, machines able to handle a specific task very well, but they don't generalize to other tasks that they haven't been trained for.
But general AI is the future of AI. It represents a machine that's capable of performing any generalized task, much as a human would be able to, but faster, better, and more efficiently.
So that's actually, I suppose, taking a step towards the AI we see in films. That's general AI.
Yeah, we're still decades away from achieving this general AI.
But that doesn't stop us using the narrow forms of AI to solve problems. Narrow AI is a brilliant tool for us as developers because we can train models for a particular purpose and they perform really, really well in their given situations.
And these are the models that exist today. Machine learning is an application of AI that refers to machines having the ability to automatically learn and improve from experience. With machine learning, we don't explicitly code the rules. The computer learns the patterns and makes predictions by itself, given data.
The data doesn't always come as numbers, though.
No.
It's because it's important to remember that the input to these algorithms, these machines are always used and they understand numeric data. The information may start as a piece of text, a sound clip or an image or a video, but it always undergoes a transformation because the computer needs a digital representation of the information.
So the main sections in machine learning are supervised learning, where the machine learns a function from a predefined input and output data set.
So stuff like that, we're thinking, predicting house prices, where it's just, predicting one number given a load of input.
Yeah. Then we've got unsupervised learning. So this is self-organized learning, finding patterns without any known outcomes.
Stuff like that, we're thinking cluster algorithms where you group, people together based on the similarities.
And reinforcement learning, where the machine learns from experience and given a situation and a target optimal outcome.
There's some really cool applications of this, Machines have actually learned how to play Super Mario from scratch, where we don't even tell them what the buttons mean. They have to figure out how to move and then go on and complete the levels.
Sound like you've watched a few of those videos.
A few.
And finally, we've got deep learning, which is a particular subset of machine learning where artificial neural networks are used to learn from vast amounts of data. And usually this is applied to more complex tasks that require deeper and more powerful models.
Google's got some great applications of deep learning. We already touched on one in a previous video of AlphaGo, but Google Translate is probably one that you're more familiar with in your day-to-day.
Yeah, and any sort of image recognition will more than likely use deep learning models now. It's very easy to think very clearly when we split it into these two types, narrow versus general.
So we're going to focus in the next video on a few more of the narrow AI applications.